Hi, I'm Mr. Rutherford. In this problem, we will learn how to solve a system of equations by graphing. Graph each system of equations. Then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. A. Y equals 1/3 x minus 3. X minus 3y equals -3. Our first step in this problem is to rewrite these two equations into slope-intercept form, which is y equals mx plus b. Now we notice that this first one here is already in slope-intercept form. So I'll write this as our line 1, y equals 1/3 x minus 3. So this line has a slope of 1/3 and a y-intercept of -3. Now our line 2, which is written x minus 3y equals -3, we need to rewrite this into slope-intercept form. And to do that, I first need to subtract x from both sides of the equation. And so I'll have -3y equals -x minus 3. Then I'll divide both sides of our equation by -3. And so I'm left with y equals 1/3 x plus 1. So this line 2 has a slope also of 1/3 and a y-intercept of 1. Now, one thing to keep in mind is that any time we have two lines which have the same slope, which in this case is 1/3, but a different y-intercept, they're going to be two parallel lines. So let's graph them and just check that here. So we'll need to make a table of values for both of our lines. So line 1, and I'm just going to choose 3 values to plug in for x. In each of our equations. So for our line 1, if I choose three different x values of -3, 0, and 3, I will get for my y values, I will have a -4. If I plug in 0, I'll get -3. And if I plug in 3, I will get -2. I'm just plugging these x values into our equation, y equals 1/3 x minus 3. Now for our line 2, I'm going to plug in the same x values, -3, 0, and 3. Now in this one, when I plug in -3, I will get 0 for my y value. If I plug in 0, I will get 1. And then if I plug in 3, I will get 2. So let's graph each of these lines individually here. So first, let's graph line 1. I first have a point of -3, -4. Then I have a point of 0, -3, and a point of 3, -2. Now I can connect these dots with a straight line. And do your best. You can use a ruler or you can use freehand, but do your best to draw a straight line there. And now I have my line 1. Now line 2, we have a point of -3, 0, 0, 1, and 3, 2. And again, I need to connect these dots with a straight line. And there I've constructed my line 2. Now, as we said in the beginning, we have the same slope, so these two lines should be parallel. And notice they are parallel, and they do not intersect at any point. So our solution for this is no solution. B. x minus y equals 3. 2x minus y equals negative 1. As in part A, we need to rewrite these equations into slope-intercept form. So our line 1, which is written x minus y equals 3, we need to rewrite this, so I will subtract x from both sides, and we have negative y equals negative x plus 3. But here we have a negative coefficient of y, and we can't have that. We need to have a positive y. So I can either divide both sides of our equation by negative 1, or I can multiply by negative 1. Either way will work. So what that's going to do, if I divide by negative 1 on both sides, I will get an equation of y equals x minus 3. So notice that our signs just flipped in each case. So here's my line 1, y equals x minus 3. In my line 2, we have 2x minus y equals negative 1. Now I need to subtract 2x from both sides. And so now I'll have negative y equals negative 2x minus 1. Now in this case, because we know each of the signs are just going to flip, I'm just going to change those to y equals positive 2x plus 1. So this is my line 2. Now we need to graph these to see how many solutions they have. One thing to take note of, we notice that in line 1 we have a slope of 1, and in line 2 we have a slope of 2. So that would indicate that these two lines should cross at one point, and we should have one solution. But we need to graph to check here. So let's set up two table of values, one for our line 1, and another for our line 2. Okay, for our line 1, I'm going to choose the points negative 1, the values for x of negative 1, 0, and 1. When I plug in a negative 1 for x, I will get negative 4. When I plug in 0, I will get negative 3. And when I plug in a 1, I get negative 2. Now for my second equation, line 2, I'm going to also choose the same x values, negative 1, 0, and 1. And when I plug in a negative 1, I get negative 1. 0, I get a 1, and when I plug in 1, I get 3. Okay, let's go ahead and graph these now. So for our line 1, I have negative 1, negative 4, 0, negative 3, and then 1, negative 2. And this is my line 1. Now for line 2, I have negative 1, negative 1, 0, 1, and 1, 3. So let's go ahead and graph that line. And make sure you get the arrows on that. Now, as I said in the beginning, because we had different slopes, we should have one solution. Now we notice that these two lines, line 1 and line 2, cross at one point here. Now, we can look at this point, negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we have a solution of negative 4, negative 7. So let's just check and see if this is in fact our solution to both equations by substituting these values in for our x and y. So for line 1, our y value is negative 7, so negative 7 equals our x value, which is negative 4 minus 3. Negative 4 minus 3 is negative 7. So that one is a solution for our line 1. Now let's check line 2. Line 2 will have our y value, which is negative 7, equals 2 times negative 4 plus 1. So simplified, we'll have negative 7 equals negative 8 plus 1. And we simplify that, and we get negative 8 plus 1 is negative 7. So once again, this point, negative 4, negative 7, is a solution to this system of equations.